Hello students, this is the second session of the lesson Refraction of Light at Curved Surfaces. So, in the previous session we have seen the behavior of light rays, behavior of some light rays when they are incident on the lens. So, in this class we will start with how to draw the ray diagrams of for the lenses. So, the ray diagrams will give how the image formations will be occurred with lenses. So if you consider the lens, you can observe a magnified image. If you observe the lens, if you are observing any objects through this lens, you will observe a magnified images. So just keep the lens on a letter. There are some letters on the book, and I was observing the letters on the book through the lens. So if I keep on increase the distance, the size of the letters will be increases. The size of the letters will be increases. So after some particular distance, you will find some blur images. So the size of the letters are increased to some particular distance only. After that distance, you cannot find the magnifying of the images. So after that particular distance, the lens cannot form the images that can be observed by the eyes. It will form the images which are real images. So those images cannot be observed with the eyes. So here, this is the image observed by our eyes. It is a visual image. So after some particular distance, you cannot observe the magnification of the letters, and at that distance, the lens was forming a real images. So to observe that images, you need to place some screen. So let us look into that, how that magnifying images were observing, how the lens can form the other type of images. Let us look in this class. So to know the formation of images, we need to draw the ray diagrams of the lens. So let us design what are the rules to draw the ray diagram. So I have considered a convex lens, and the center of this lens and the midpoint of the lens is called as pole. This is center of curvature C2, and C1 will be situated in the right hand section of the lens C1. So this is F2 and this one is F1. And keep an important point in your mind. That is, you have to place the focus point exactly at the middle of center of curvature and pole. Then only you will get proper ray diagram. So now we are discussing rules to draw the ray diagram. Rules to draw ray diagram. So to explain these rules, I have considered a convex lens and an object is placed beyond the center of curvature C2. So what is the first rule is, select the tip point of the object. Select the tip point of the object. So the first rule is, select the tip of the object. Select the tip of the object. So, and in the previous session we have seen some behaviors of light rays, and from that behavior of light rays, draw two light rays, and I was drawing the two light rays. One is parallel to the principal axis, and another light ray passing through the pole. So select two light rays from that point, from that selected tip of the object, and draw two light rays from the previous situations that we have discussed in the previous session. In the previous session we have discussed some behavior of light rays, and from that behavior of light rays, select two light rays. So here I have selected the light ray which is parallel to the principal axis, and the light ray parallel to the principal axis will be refracted in such a way that it passes through the focus point F1, and undeviated path. Will follows an undeviated path. So after selecting the tip of the object, select two light rays. Select two light rays from the behavior of light rays on the lenses. So after selecting the two light rays, you need to draw the refracted light rays. And extend those refracted light rays until they are get intersected. Here the refracted light rays are intersected at this point. So you need to extend this refracted light rays until they are intersected. Extend refracted light rays. Extend refracted light rays until they get intersected. So now, from that intersection point, draw a line normal to the principal axis. From this intersection point, draw a line normal to the principal axis. So from this intersection point, I have drawn a line normal to the principal axis, and this line indicates the image of the object. So what is the last point? From the intersection point, draw a normal line on principal axis. So that line represents the image of the object, and the length of the image, if you observe here, the length of the image is smaller than the length of the object. So the length of the image depends on the distance of the object and the distance of the object from the lens. So these are the rules to draw the ray diagram. So let us draw ray diagram for the convex lens by placing the object at different distances. Let us draw ray diagrams of the convex lens. Ray diagrams of convex lens. Ray diagrams of a convex lens. So the first case is case 1, when the object is at infinite. The case 1 is object is at infinite. The object is situated at infinite position. That means the object is situated at a very long distance. That means if you are observing the moon, what is the distance of the moon from the earth? It is very long distance, so it can be considered as an infinite distance. So let us consider the case when the object is placed at infinite distance from the lens. So the lens can be represented as a double-headed arrow. The midpoint of the lens is called as pole. Center of curvature C1 and focus F1. Center of curvature of the second circle C2 and focus F1. So when the object is at infinite distance, the light rays can be considered as parallel light rays. When the object is at infinite distance, the light rays coming from the object can be considered as parallel light rays. So what happens when parallel light rays incident on the principal axis, on the convex lens? Those will be focused to a point. And you will observe a point-sized image at the focus point. So when the object is at infinite, point image will be formed at focus, point image form a focus point. So when the object is placed at infinite distance, the light rays coming from the object can be considered as parallel light rays. So when parallel light rays incident on the convex lens will be focused to a point, that is focus point f1. So a point image will be observed at f1. When the object is at infinite, where the image will be observed? The image will be observed, point image will be observed at focus point. So let us see the case. Case 2. Object is beyond C2. Object is beyond the center of curvature C2. What happens in the case when the object is placed beyond the center of curvature C2? So I have placed a convex lens. So the line joining the pole and the center of curvature is called as principal axis. So I have now, in the second case, I have placed the object beyond the center of curvature C2. So what is the first rule? You need to select the tip of the object and draw a light ray parallel to the principal axis. And this light ray which is parallel to the principal axis will get refracted by passing through the focus point. And consider another light ray passing through the pole and extend these refracted light rays until they get intersected. This was already drawn in the while we are discussing the rules. So from the intersection point, draw a line normal to the principal axis. And this line represents the image of the object. So this is the image. When the object is placed beyond center of curvature C2, the image will be observed between the focus point F1 and C1. The image will be observed between the focus point F1 and C1. And this is the real image. This is the real image. What is the nature of the image? Image is real image. This image is real image. So how can we know this is a real image? So this cannot be visualized through your eyes. It cannot be viewed through your eyes. You cannot observe this image with your eyes. You need to place a screen here. You need to place a wide screen here. Then the image will be observed on the screen. Such images are called as real images. What is meant by real images? The images which can be projected on the screen can be called as real. So here the real image, the image which can be projected on the screen is called as real image. So let us see how the real image will be formed. So this is the convex lens. This is the convex lens, and there is a window in the right hand section of me. So let us see the image of the window will be observed on the screen. The image of the window will be observed on the screen. So if I place convex lens like here, so you can observe the image of the window on the paper. So this image will be called as real images. So those images cannot be viewed through your eyes. Those images will be observed only when they are projected on the screens. Such images are called as real images. The images which can be captured on the screen are called as real images. And if you observe the direction of the object, it was inverted. So here the image form is an inverted image. Inverted image. And if you observe the size of the image, it is smaller than the size of the object. And hence it is a diminished image. It is a diminished image. So when the object is placed beyond center of curvature, the image will be observed in between focus point F1 and C1. What is the nature of that image? That image is a real image. That image is a inverted and diminished. Real, inverted and diminished image will be observed when the object is beyond center of curvature C2. So let us see another case. when the object is at center of curvature. So here, initially we have considered object at infinite distance. Later we have considered object placed beyond center of curvature. Now consider when object is at center of curvature. An object at C2. So again, convex lens, pole P, this is the center of curvature of the second surface C2 and C1. So to obtain ray diagrams properly, you need to place the focus point exactly in the middle of pole and the center of curvature. So this is F2 and this one is F1. So now consider an object at the center of curvature C2 and draw the ray diagram for it. So to draw the ray diagram, consider a light ray parallel to the principal axis, and this parallel light ray will pass through the focus point, and consider another light ray passing through the pole, and this light ray passing through the pole will follow an undeviated path and it will get intersected. Extend the refracted light rays until they are intersected. So from that intersection point, draw a normal line. So you can observe the image is obtained at the center of curvature of the other side of the lens. When the object is placed at the center of curvature, the image will be observed at another center of curvature. And what is the nature of this image? The nature of the image and the size of the image is same as the size of the object. Here, the nature of the image is it is a real image. It is a real image. That means the light rays are really intersected here. The light rays are really intersected here. So that's why you can capture that image on the screen. So here the image is real, inverted, and equal size as that of the object. Equal size as that of the object. So let us consider the fourth case when the object is placed in between center of curvature and focus. The fourth case is when object is between C2 and F2. So let us see where the image will be observed and what is the nature of the image. So again I have considered a convex lens. This is the pole, the midpoint of the lens. So this is the center of curvature of the second surface C2, F2, and again F1, C1. So now we are placing the object in between center of curvature C2 and F2. So I have placed the object between center of curvature C2 and F2. So draw a light ray parallel to the principal axis, and this light ray parallel to the principal axis will refract in such a way that it passes through the focus point F1. So this is the path taken by the light ray and it is parallel to the principal axis. And consider light ray passing through the pole. So the light ray passing through the pole will follow an undeviated path. And it will get intersected there. So if you observe the image size, it is larger than the size of the object, and it is reverse direction. It is in the reverse direction to the direction of the object. So what is the nature of the image? The image is real. The image is real, inverted, and enlarged image or magnified image. Magnified image will be observed when the object is in between C2 and F2. So the object is in between C2 and F2, a magnified, real and inverted image will be observed. So let us say P, the line joining the pole, and center of curvature is principal axis. This is the focus point F1. focus point F1. So now place an object at F2. So when the object is placed at F2, so to draw the ray diagram, you have to select two light rays. So first selected light ray is parallel to the principal axis, and this light ray will be refracted as it passes through the focus point. And consider another light ray passing through the pole. So if you observe these two refracted light rays, these refracted light rays are parallel to each other. These refracted light rays are parallel to each other. So if you extend these two light rays, they won't get intersected. They won't get intersected. That means where they will intersect? They will intersect at infinite distance. The parallel light rays will intersect at infinite distance. Hence, the image will be observed at infinite distance. Image at infinite distance. So infinite means undefined. Where the image will be observed, we cannot know. Infinite means it is undefined number. So since we didn't get any image formation, so no need to discuss about the nature of that image. So whether it is a real image or virtual image, we didn't know. Why? Because the image was not obtained. The image will be observed at infinite distance when the object is placed at focus point F2. When the object in between, when the object is between focus point F2 and pole P. So I have considered a convex lens, the line joining the pole and center of curvature is called as the principal axis. So now place an object in between focus point F2 and pole. Place an object here. So let's draw a ray diagram for this object. So consider a light ray parallel to the principal axis, and the light ray which is parallel to the principal axis will pass through the focus point. And consider the light ray passing through the pole, it follows an undeviated path. So these light rays are going away, hence just extend these light rays in the backward direction. If you extend these light rays, these will get intersected at some point, and there you will observe the image of the object. There you will observe the image of the object. So the image will be formed at this point. And if you observe clearly, these are not the intersection of real light rays. I have just extended it in backward direction, and hence this is not it is not a point of real light rays of intersection. Whereas if you see in these cases, the light rays are really intersected there, but here the light rays seems to be coming from this point, and hence the image is visual image. The image is visual image. And what is the nature of this image? It is a visual image. Visual image means it can be observed by our eyes only. It cannot be projected on screen. So visual image and magnified image, and it is in the same direction as that of the object. The direction of the image is same as the direction of the object, and hence this is an upright image, not an inverted. It is an upright image. So when the object is in between F2 focus and pole, the observed image is a visual image, magnified, and upright image will be observed. So let us know clearly about the formation of images of this convex lens. So we have seen different cases for the formation of images. So there are some letters on this book, and those letters will act as an object. So if I place the object in between the focus point and pole, you will observe a magnification. When the object or the letters here, if the letters are in between pole and focus, then only you will observe magnification. When the object is beyond F2, then you will observe real images. Then you cannot observe the virtual images. Then you cannot observe the magnification. Okay, the magnification will be possible when the distance between the lens and the object is in between pole and focus point. So these are the ray diagrams that can be obtained by these ray diagrams will explain the formation of images by the convex lens. So till now we have discussed about ray diagrams of convex lens. Now it is time to discuss ray diagram of concave lenses. Ray diagram by a concave lens. So let us consider a concave lens, and the midpoint of the concave lens is P, and center of curvature of the first surface C1, focus F1, center of curvature of the second surface C2, focus F2. So let us see the case when the object is placed at center of curvature C1. So to draw the ray diagram, you need to draw two light rays. So the first light ray parallel to the principal axis, and the refracted light ray by the concave lens will move away from the principal axis and appears to be coming from the point F1. Appears to be coming from the point F1. And draw another light ray passing through the pole. Passing through the pole. If the light ray is passing through the pole, it follows an undeviated path. So where these two light rays are intersected, these two light rays will not intersect in the right hand section. Here the intersection will be observed. Here the intersection will be observed. So this image, what is the nature of this image? So the nature of the image is visual. The nature of the image is visual. Why? Because one light ray is extended in the backward direction, but it is not the real light rays of intersection. So it is a visual image, and the size of the image is small when compared to the size of the object, and hence it is a diminished image, and it is not inverted. It is straight in the upward direction only, same as the direction of the object, and hence it is a upright image. So the image is formed in between the focus point F1 and pole. So wherever the object will place for a concave lens, the image will be observed in between focus point F1 and pole. So this is so of course it changes the distance between the object and the lens. The image will be observed in between the focus point and the pole only. So let us take another case when the object is placed in between C1 and C2. Let us verify that also. So I have considered concave lens, pole, center of curvature C1, focus point F1. So center of focus point F2, center of curvature C2. So again, initially I have placed the object at C1. Now place the object in between focus point. And center of curvature. So now draw a light ray parallel to principal axis. The refracted light ray by the concave lens will move away from the principal axis and appears to be coming from focus point. So consider another light ray passing through the pole, and it follows an undeviated path. So here also the light rays are intersected here. And if you observe the both diagram, in both the cases, the image is visual and it is formed in between focus point and pole and an upright diminished image. In both the cases, the nature of the images are same. So for a concave lens, whatever the object distance, wherever you have placed the object, the image will be observed in between focus point and pole. And the nature of the image that is formed by a concave lens is always visual. The concave lens will form always visual images, and it will always form diminished images, and it will always form an upright images. So what is the lens which can only form virtual images? That is concave lens. So which lens can form both virtual and real images? That is convex lens. So these are the ray diagrams of concave and convex lenses. So in the next class, we will learn about the relation between the focus point, image distance and object distance by lens formula. So with this